Hey, I just want to demo this Desmos graph I made a couple days ago that is exploring the general sinusoidal function equation. And so if we take a look up here, we've got y equals a sine of b times x minus h plus k. This is actually the equation that we're exploring here. And what this graph lets us do is use sliders for a, b, h, and k and kind of explore what's happening to not only the function and its graph, but also what happens to the unit circle as we change those numbers. The unit circle, of course, being conceptually what generates the sine function anyway. So the key part here is the portion, the variable down here called r, or r sub ad, rad, stands for radians. That's the angle measure that gets changed. And so if we look over here, we can find the unit circle, and the center is highlighted there in purple. So let's just take a look at what the sine function does when we generate. So that r angle gets swung around on an arm around the unit circle, and then the sine, which is the height from the midline up to the circle itself, that height or that length there is translated over to a height on the graph, and that's where all the new points from the sine graph come from. And so we can move r all the way out. I've got it set up to 4 pi, and so there's 2 whole cycles or 2 whole waves of the sine function. So what happens when we change a? What a does, it's actually change the radius of the unit circle. So if we change that radius to 2, what happens is we get a sine function with a much higher and lower minimum and maximum, and as we know, that's called the amplitude of the sine function. So that's kind of a neat thing there, and then we can make that a whole lot smaller. And so now we've got a really tight looking sine function whose amplitude is 1/2, very small. So let's move that back up to 1. What does b change? Well, we might know already that what b tells us is that's how many times a full wave or a full cycle is going to be completed by the time the graph gets to 2 pi. A lot of students memorize in school that 2 pi divided by b is the period of the function. And I like to think of it more as this indicator of how many cycles do we get finished with from 0 to 2 pi. So we can move over, if we increase b up to 4. So in theory now we should get finished with 4 full cycles before we end up reaching 2 pi on the x-axis. Let's see if that's true. And so what's happened here is horizontally, this graph has shrunk quite a bit. So all the way out to 4 pi gets us pretty far. So does this actually get, here's 1 cycle, 2, 3, yeah, 4 full cycles before 2 pi. So it's kind of neat there. And h and k move the center of the circle around. So h moves us in the horizontal, k moves us in the vertical. So if we let k be 2 and then h maybe be about like 1.5, pretty close to a pi over 2. And let's see, what if we changed a, made it a circle of radius 2. If we changed b over to maybe 1/2. Let's just let r play out. So going up. And so we would expect, because b is 0.5, we would only get through half of a full cycle. in the space of 2 pi. And of course, since we're starting at 1.5 on the x, it's not really by 2 pi. It's really by 2 pi plus 1.5. So this is the generator, and what's neat is as R is playing, we can, of course, come back in and even change these values even while the animation is going on.